Let's see if everything's working. I don't... This is streaming out to YouTube, right? Yeah, it's going to YouTube. Is it public? It is public. Didn't say starting at 8 p.m., right? Yep. Okay, looks like everything's working. You know, maybe I should have asked people to just like put in some like submissions ahead of time. So that we don't like so that these streams don't always start with this oh, actually, well, that solves that issue. Um Oh, I forgot to set this up. Uh Okay, there we go. So, of course, we start with a 7800X 3D. Why am I not surprised? Can we sub with Dragon Ball? Yes, though I'm not a fan of it. But it's tolerable. Anyway, so yeah, we've got a 7800X 3D running 6000 CL28, 35, 35, 35, 30, 65. Okay, so primaries are good. And this is at reasonable SOC voltage. So, yeah, B650E Tai Chi. I mean, yeah, like, so nothing really special. Oh, right, ASRock doesn't enforce timing limits. So, we got this, which is physically impossible. So, that's a thing. So that's probably getting auto-corrected to, like, 4. Yeah, it should be getting auto-corrected to 4, or it should be getting auto... It should be 4, I think, that it auto-corrects to. T-Fall 20. It just confuses me. Like, why would you have this at, like, because they don't enforce the T-Fall limit either, as far as I know, on ASRock boards. Anyway, WTRS 2, that's surprising. That doesn't normally go that low, but neat. Like, usually I expect that to bottom out at, like, 4, but, yep, neat. WTRL 14, neat. TWR minimized. TRFC 462. And then we've got memes for TRFC2 and TRFC SB at 420 and 69, because they don't actually do anything. TRDSCL4, WRWRSCL2. Okay, so that's cool. RTP12, TRDWR13. That's really tight. And maxed out TREFI. So, yeah, pretty generic Ryzen timing things. Oh, and also 2200 FCLK. So yeah, pretty generic Ryzen things. Very sensible voltage for CL28. 1.4 VDD. Pretty solid sticks. So we'll take the next submission. Ooh, a 12700 on a B650M. Wait, is this one of the boards that supports the non-K overclocking, or is just... Because MSI has one that does non-K overclocking. Is this one of those? And wait, this is DDR4. Oh, right, because you have a non-K CPU, so you don't get to change your system agent voltage. And if you don't get... Though, even if you can't change your system agent voltage, I would think you would be probably able to run like 3400 or 3466. Like, yeah, 3600 usually requires more than the 0.9-ish stock VCCSA. But you shouldn't, like... Yeah, you shouldn't be stuck at 3200, I don't think. Like, you should be able to run like 3400. You could also experiment with Gear 2, because it might actually be faster than Gear 1 when you can't change the system agent voltage. Though I'm not 100% certain about that. Anyway, what is this? This looks like... Micron? Maybe? No, it's kind of Hynix look. This is so low. The clock is so low that like I can't tell what this is. Okay, 15, 9, 19, 18, 28, 2T. Is this single rank? I'm gonna go with no, because your DR and DD timings are tweaked. Or at least some of them are. Why is TRD same group so high? Like, this is DDR4, you should be able to run that at 4.4. TFall 36. Is this JEDEC? This can't be JEDEC. That TREFI. Wait. Is it? No, 37,000 is not JEDEC TREFI. This is a mess, is what this is. Because we got, like the TRDs... This is Micron, isn't it? So... Yeah, I would try to run the TRDs at 4.4. RTP12 is fine. TFall definitely to 16. Like, at 36, you're losing so much performance. Like, this is really bad. And TFall 36 is really, really bad. And then for the tertiaries, 7.4, that's fine, I think. Like 7.4, 7.4. These are loose. Though I'm not sure how much tighter they can go, but these are loose. Those could, like, you could tighten those. And then if this is dual rank, then also, like tighten the dual rank timings. I'm not really sure what settings you would actually use with this, but... Because I can't even tell what die this is, but, like, this... In this configuration, this is bad. And you could try raise the TREFI a bit more, but at this point, I don't think... Like, you're already at 37,000, so raising it more is not going to be, like, a huge deal. But the T-fall being 36 is, like, that's a disaster. Let's take a look at the next submission. Why is T-fall minimum 20 if TRDs can be 4? I don't know. Ask AMD. That's just, like, what their memory controller does. Anyway, we have a Ryzen 5 7600 running 6000. Oh, and you've kindly provided the voltages. That is a lot of SoC voltage for DDR5 6000. Yeah, like, I mean, you could have a completely potato CPU and actually require that much SoC, but, like, that is a lot of SoC voltage for 6000. Yeah, I find that very surprising. 2000 FCLK. Well, with that SoC voltage, you probably aren't able to run 2200. But anyway, let's go through these. So 30, 36, 36, 34. A die, I'm assuming. Yeah, this is probably A die. 34, 30, 64. So that's fine. TRD's 4, 820. Cool. WTR's 214. Cool. TWR 48. Like, apparently WTRS at 2 is a thing. Um, that's new to me. I usually run it at 4, but cool. TRFC 360, yeah, so this is 8i, because that really low TRFC. Then we have the two TRFCs that don't matter. TRD SCL at 5? Is this memory controller just... Okay, this memory controller is just bad. Because I kind of suspect that the RDRD SCL limit is like actually like a memory controller thing a lot of the time. Because like the AMD memory controller, I am not sure if it can actually write frequently enough to hit the limit of the WR SCL timing. But read, it can definitely hit that. And yeah, so I guess that might, like, I guess this CPU's memory controller, like, this has to be the worst Ryzen 7000 memory controller I've seen. Because, yeah, 1.25 SoC for 6000 is just insane. Anyway, RTP12, TRDWR16, WRD2, cool, and then we have a bunch of timings that don't matter because this is a single rank setup, and then TREFI at 45,000. I mean, with TRFC at 360, it doesn't really matter if your TREFI is 45,000, like, or like if it's 45,000 or 60,000. I'm just surprised that like you have really fine-tuned TRFC and like sort of a bunch of other timings, and then TREFI is at like 45,000. But I guess you don't want to worry about like cooling the memory sticks or something. So yeah, like good settings. Shame about the memory controller though. Thanks Fractured Life for the super chat. Wait, is it super chats or I don't remember what it is for YouTube. Okay, next submission. We've got a, what is this? A 5800X3D with Hynix memory. So, yeah. Okay, so 18, 8, 21, 20, 21, 29. Oh, so that TRC isn't real, probably. TRD SNL 4416 and TFall 16, so that's good. WTR is 48, cool. TWR 10, cool. TRFC. This is like one advantage Hynix has over Micron is that they generally do lower TRFC. Also, this is dual rank, isn't it? Yeah, dual rank. And then 44166 and 4466. Yeah, so all the timings are good. Like it's Hynix, so it's like yeah, this is Hynix timings. That's just what they look like. So yeah, nothing to change there. This is at 3800 on a tough gaming B550 plus, so Asus board. And is this 4x8 or 2x16? Oh wait, this is 16 gigabit D-die. Wait, so this is single rank? I did not know 16 gigabit D-die exists. Interesting. Well, that makes this, like, from a performance perspective, that makes this worse. It's like, your timings are like, you have Hynix timings, which are just kind of not great, and then it's like, yeah, and you also are on single rank, so you can't even, like, there's no rank interleaving to compensate for the timings. I think my motherboard ignores my TRC values, no idea why I can get it so low. No, it doesn't ignore your TRC value. The way TRC works is if TRP plus TRAS is bigger than TRC, then TRC doesn't do anything. So your TRC here is effectively 41. Now, on the DDR5 memory controller, I think that actually changed. But yeah, on the DDR4 memory controller like Ryzen 5000, 3000, you can set TRC to like 21 as long as your TRAS and TRP aren't set too low. Or you can set your TRAS to 21 as long as your TRC isn't set too low. So you can like choose which of them you actually use because whichever, like if one of them is too low, it just sort of gets overridden by the higher one. Anyway, so yeah, like there's nothing really to complain about in terms of timings here. It's just like single rank Hynix 16 gigabit memory chip. So it's not from a performance perspective. This is probably not like this is not great. But you're all at 5800 X3D, so this doesn't really matter. Like it won't be affected as badly as some other CPUs. Okay, next submission. We've got a 13600K and right hardware info for timing readouts. Okay, cool. Oh, this is DDR4, and it's not. What? Why is this so slow? Bro, why are you freaking submitting your XMP profile? Some Corsair memory sticks. Probably Micron. But this is everything about this is bad. Like, it's just like, it's an XMP profile. It's bad. You don't even really need to check. But anyway, so all the okay, so the primaries, depending on what this is, the primaries might not really get much better, but that TRFC is a catastrophe. Oh, and it's single rank, so extra bad. TFAW 36, TRRDs of 4.8, just, yeah, TREF 512,000, so it's an XMP profile. Like, everything about this is terrible. TXP 10, I mean, that's not, like, the power down timings aren't that important. The guy asked if he can make it any better. Well, yeah. Yeah, you can, because this is an XMP profile. I don't know why you would think that this would be good. Like, depending on what memory chip this is, like, first step, I would try to clock it higher. Especially since, like, you have a K-series CPU, so, like, you don't even have the VCCSA limits that the non-K chips have. Yeah, and then just, like, tune, like, the most important one here would be TREFI. TRFC, I'm guessing this is, like, 16 gigabit micron, in which case TRFC is probably not going to go very low. So yeah, I'd prioritize TREFI. And you should be able to just set straight to like 40,000 or 50,000, and that alone should help quite a bit. Then the TRDs, I would try like 4.5 or 4.6 and TFAW 16. Then the primaries, if you're trying to go higher clocks, honestly, if this is Micron, you might be able to do 3600 without even like loosening the primary timings. Or though I would also potentially just like set them to like 1822 and then see what kind of clocks the memory can do. Low TFAW will be sawed if what? Okay, I should have not read a random question because without context that doesn't make any sense. Anyway, so let's move on to something that there's like something to react to other than just like, you know, it's an XMP profile. It's bad. Okay, cool. So next we've got a 11900K running. I love how you have the two CPU tabs. So this is the classic mistake with making hardware bot submissions where you open up your two CPUs and forget to switch one of them to memory. Okay, so this is BDI 3733 14 14 14 26 2T. Yeah, because the thing is, like, 11th gen in Gear 1, it doesn't clock super high on the memory. 44, 260. Why is your TREFI so low? Are you, like, hotboxing these memory sticks? Why isn't your, like, you know, I can understand not setting it all the way to, like, 65,000 if your memory sticks are running really hot or something, but, like, Why not 30,000 or like 40,000 or like something? Um, Anyway, TWR is on auto, RTP12 fine, TFAL 16 cool, TCK4, WCL 14, yep, that makes sense. And then, is this dual rank? Yeah, this is dual rank. We've got 7, 4, 12, 12, 7, 4, 36. These can go tighter. Um, and then, looks like you left all your dual rank timings on auto as well, which is definitely costing you performance. Um, I'm pretty sure they could, like, instead of like 9, I'm not sure about read to write, but the nines could almost certainly be sevens, I think. Might even be able to go below that, but well, maybe not the writes. And write to read, these should be able to go lower as well. Um, so yeah, so like good job on like your primaries and TFAW and like, but like you have all these tertiaries and those do matter quite a lot with Intel CPUs. Really all CPUs, right? Because like these are the timings that like affect your continuous operations, where like you have a chain of read operations and write operations, and that's what these timings control. Um, so yeah. And then in terms of voltages, I'm assuming this is like 1.5 volts on the memory. And we can't see that because this is hardware monitor, so that's cool. Um, yeah, like like especially well, write to read. I'm not sure. Like you can see how like well, yeah, the reads are fine, and then everything like the writes in the copy are not great, and that's probably because of the tertiaries being kind of horrible. Um, Also known as being on auto. Um, but yeah, so that's that. Let's move on to another submission. Are you a computer engineer? No, I'm a second year computer systems engineering dropout slash failure. Because it's not like I decided to stop going to uni. I just didn't get results. Let's just put it that way. Um, as it turns out, just showing up isn't always enough. Anyway, we've got a 7800X3D on a B650M with either the world's worst memory controller or you just couldn't be bothered to actually tune the SoC voltage. Because there is like no way you need 1.3 for 6,000. Yeah, because that just doesn't make any sense. Also, if you lowered that SoC voltage, you might be able to run higher FCLK. Anyway, let's go through these timings. 28, 35, 35, 35, 28, 62, 4, 6, 14. So we've got another motherboard that it doesn't enforce. Oh, right, it's an Asus board, so of course it doesn't enforce the timing limits. So this is probably just getting auto corrected to 20. WTR is at 214. Neat. So apparently that's just me being lazy with the WTRS timing and not setting it to 2. Because like this is the third submission we've had where somebody has it set to 2. I think, today. So evidently that just does work. Um, TRFC, like the thing is, when it comes to memory timings, I don't often go out of my way to minimize every single timing. Which is how, so like, it's like, and I think WTRS on default is like 2 digits a lot of the time. So if, you set it to 4, it's actually way faster than auto. And not really that much slower than 2. But evidently 2 works fine. And then TRFC 390, so this is probably a die. SDL's at 4.4, cool, RTP 12. This is single rank, so TRD 16 and WRD 1. And maxed out refresh interval. So yeah, good timings, but I do not understand why the SoC voltage is that high, because it really doesn't need to be. Okay, so we've got the first super chat timings, so let's just go straight to those. You have like 10,000 seconds, so like 3 hours of Y cruncher basically on a dual rank 96 gig setup. Nice. Well, I'm not sure if well, I guess nice because it is running 6400 and it is 1-to-1 mode and it's doing 2133 FCLK. Man, this memory controller is a beast. Like this is 1.224 SoC voltage for DDR5 6400. Like this is a really good CPU. Um Yeah, this is a really good CPU. It's also on a X670E Gene, but at in 1-to-1 mode, in my experience, it's really not about the motherboard. It's just like, can your CPU do 3200 UCLK with less at low voltages? So yeah, this is a crazy CPU. Actually, it's not that crazy because there are some chips that'll do even like 6600, but like 6400 at like just a bit over 1.2, like that's up there in terms of silicon quality. 30, 37, 37, 37, 32, 69. Right, because 37 plus 32, yeah, that works out. The TRRDS 8, TRRDS 12. Oh, right, MDI. So 24 gigabit MDI. Yeah, that doesn't really. I mean, TRRDS can sometimes go a bit lower with it, but that is one of the weaknesses of 24 gigabit MDI is it really doesn't do, like, it doesn't tend to do low TRRDs, so that's not too surprising that that's that way. WTRS4, WTRL16, TWR minimized at 48, TRFC 600, yeah, that's just MDI things, like 24 gigabit MDI things right there. SCL's at 4 and 2, nice, RTP12, and then dual rank timings at 6688. Yeah, and maxed out refresh interval. Um, yeah, so this is good. Like, there's nothing I would change about the timings. Really nice memory controller. TRAS 32 is the lowest I can set for 6400. Lower than that will make Y Cruncher upset. Yeah, that's a thing. Like it's kind of like that. That's just yep. That's a thing. Like some memory sticks just don't do super low TRAS. TRP 32 is impossible even at 6200. Yeah, the MDI like 24 gigabit MDI doesn't like is looser than the 16 gigabit memory chips. Just kind of across the board, not by a huge amount, but it is just looser across the board. Um, Maybe check the thermal pad on the chipset, because I've seen this before. Asus, or actually I think it was Asus, where they like had a few. I think it was ITX boards where they forgot to put the thermal pad on the chipset. So they might have done that again. Or I've also seen a few cases, and I don't think this was specifically Asus, but I've seen a few cases where manufacturers would like forget to remove the thermal pad, and then you get really bad temperatures. Because, yeah, I mean, I don't really check the chipset temperature very often on my boards, because it's not usually something that you should have to check, because as long as they don't forget to put the thermal pad on it, it won't run super hot. So, yeah, I would basically go check if they actually put a thermal pad on the second chipset, which I think the two chipsets share a heatsink, so you're gonna see both of them at the same time. If you go to check that, so you don't have to like figure out which chipset is which one, because I think they have the same heatsink. It could also be that that chipset is like under your GPU or something, and it's just wait, no, you said it idle. Yeah, so they probably forgot to put the thermal pad on it, or it's like not making proper contact or something. Um, which I know, like, I mean, it's not, it's not hitting like 100 degrees, so it's not the end of the world, for your chipset. Anyway, next submission. And we've got some leftover Crucial Ballistics Max 4416. Oh, that's interesting. Used by G-Skill. So this is Micron, but it's like uber bin Micron. And this is, yeah, 16 gigabit uber bin. Wait, is it? Yeah, single rank SR, yeah, so uber bin Micron 16 gigabit. 3800, 14.8, 17.17. So it's like, it's getting, it's like approaching BDI level timings. TRAS 21, but with TRC 49. So yeah, this is what I mentioned earlier, where it's like, yeah, you can set your TRAS to 21, and then as long as your TRC isn't too low, it's fine. Or you can do it the other way around, where you set your TRC really low, and then set TRAS appropriately. So in this case, this person decided to just not use the TRAS timing and just use TRC and TRP. TRDSL and TFall 4416, cool. WTR is 26. Yeah, some of the Micron ICs can do really low WTRs. TWR 18, that is weirdly high for TWR. I'm used to usually seeing it at like 10 or something. TRFC 542, that's actually really low TRFC for Micron sticks. And then SCL's at 2.2. Yep, that works a lot of the time. Or, well, with good memory sticks, and I think it might also be dependent on the CPU to some extent, like that can work 2.2. RTP8, TRDWR 13, and then everything else at 1, those aren't even relevant, like that's all dual rank. And I mean, technically you have a single rank timings in there, but it's like the different group timing, which is always 1. So, yeah. Yeah, so cool. And here we have like the part number for these like special sticks. It's not even like a crazy speed bin from G-Skill, right? Like G-Skill just like took these are really good memory chips, and G-Skill just shoved them in like freaking 3600 CL17. Oh well. Anyway, let's take a look at the next super chat submission. Got a Z790 Apex running 8532. So things I do not understand because I cannot make them work. 14900K, 14900 KS on a Z790 Apex on a core 8533 round 2. This time with HT and E cores enabled. Cool. We've also got the classic Intel stress testing methodology of like don't run any stress tests overnight. Right, where it's like, this is like 2 hours, this is like 2 hours, because if you ran it for 12, it wouldn't pass. So, this is really tight though, isn't it? 36, 49, yeah, this is really tight. 49, 48, 61. Once you get into the really high speeds, your TRAS doesn't want to get super low anymore. 2T, and then TRFC 520, TRFC per bank at 440, TRDL at 7, TRDS at 4. Oh yeah, because this is at like 1.56. These memory sticks are really good. And then WTRL at 24, WTRS at 8, RTP 12. Well, those two don't really. Yeah, so the WTR timing on Intel isn't a thing. We should be looking at like WRD, SG, and DG, so 64 and 48. So that's tight. TRD, same group, 16, different group, 8, because the memory controller doesn't support odd tertiary timings, just straight up. Like, you punch in a 15, and it's the same thing as 16. So it doesn't actually matter. Like, punching in 15 is fine, because it's the same as if you punched in 16. So this is functionally 16, 8, 20, 20, 64, 48, 16, 8. Which, yeah, that makes sense for this kind of speed. 65. Why is it 65,280? That's just a random, like, you could have, like, 65,000 with just zeros at the end. That would be, like, okay. And then 65, like, the usual register limit, or at least the old register limit was, like, 65,535, if I remember correctly. Which is just like a power of 2 thing, -1. And then, yeah, so that one, I do not understand why, I don't think it matters. I'm just confused why it isn't just like Like, I personally, I would have probably just set 65,555. Actually, no, probably 65,444, just so that, like, it's less, it's easier to see how many digits there are, right? Because if you have four fives next to each other, it makes it really hard to look at. Um, so when I have like, so I do that with my like TREFIs that I'll like, the last three will be the same number to be like, this is a group of three. Um, but anyway, yeah, so this is really tight. Um, 1.24 SA, 1.35, 1.375 VDD QTX, 1.475 VDD2. Yeah, the thing is with these voltages, as far as I can tell, they're like completely like board and BIOS and CPU and memory stick specific. So it's like this might work for one CPU and it will just completely not work for another one. Though with my CPU, like I've never even booted 8533, so for me, it's not even like it's not even like, yeah, it's just, oh well. So moving on, I'll just grab another submission and after the super chats. Oh, we have a 12900K next at 7600 on an MSI Z790i Edge Wi-Fi. Man, I can't, like, I've struggled to get 7600 stable on that board, even with 13th gen CPUs. Probably because I had the dumb idea of trying to let the stress test run for 16 hours. So, after 16 hours, like, first 12 hours, like, the first 12 hours was fine, and then it's just like, oh yeah, there's one error, like, a day later. And then I ran it for another 16 hours, and there were no errors. So it's just like, oh, well, that's dumb. Anyway, let's go through these timings. We've got 36, 45, 45. And the thing is, like, as far as I know, like, 12th gen, like, I think there's like there was a thing where the BIOSes like got better. So 12th gen, because 12th gen used to have like a hard wall at like 7200, even on 1 DIMM per channel boards. And then when like 13th, 14th gen came out, yeah, like support for high memory speeds on 12th gen got somewhat better. Though I haven't like tested it myself because quite frankly, I just hate Intel memory overclocking at this point. So the less I do it, the better, as far as I'm concerned. Anyway, 36, 45, 45, 48, 2T. Yep, so primaries make sense for this kind of speed. TRD SG20. Ugh. Yeah, ugh. Though I guess this is just like to demonstrate that this works, because this doesn't look super tight on anything. Like, yeah, TRFC and TREFI are set up, and like the tertiaries are like, well, no, WRD over here is awful, and though I'm not sure, like that might just be like a limitation of the CPU, but like, yeah, like the most of these timings, with the exception of like TRFC and TREFI, are I mean 16.8, 16.8, that's fine, but that's like auto timings for DDR5 a lot of the time. So yeah, this basically looks like primaries, I'm assuming manually tuned, TRFC and TREFI tuned, and then everything else just is auto, is what this looks like to me. 1.34 SA. Oh, and it's 24 gigabit memory ICs, so that should, yeah, probably makes running 7600 a bit easier. How much stress testing have you done on this? I'm just wondering. Like, the fact that you're getting 7600 to boot on 12th gen at all is, like, kind of cool. But Like, that's the thing with the Intel memory controllers, is it's really easy to boot a lot of things that don't work. So, I can only do 7200 with the E-cores on and 7600 with them off. Oh, that's interesting. I guess it, like, reduces the load on the ring, and that's why the E-cores would change it. One day of Karhu. Damn. So this is actually really stable then. Wait, am I... Yeah. So this is actually really quite stable. That's cool. Okay, let's take a look at another submission. Oh, it's another 7800X3D. Running generic Hynix timings. Imagine my surprise. Yep, just a 7800X3D on a B650 Aorus Elite AX running... Wait, this is Samsung? Wait, this is freaking auto. This isn't even tuned. Why are you posting this? Like, you think I'm not going to notice that you're submitting, like, Expo profiles? I'm not even sure if this is an Expo profile. But yeah, this is 36, 36, 36, so this is probably Samsung, because it's like a G-Skill kit, and that's like a pretty typical G-Skill configuration for their, like, Samsung memory, like, Samsung-based kits. And yeah, this is just awful. And mind you, like, Samsung isn't even that bad. It doesn't clock very high. I think TRFC is kind of horrible. Like, there's, like, it has timing weaknesses, but it's not, like, especially on Ryzen, it's not as bad. Like, on Intel, it's worse, because on Intel, you can actually, like, run high memory speeds, and Samsung doesn't do those. But on Ryzen, like, if you're in one-to-one mode, you're not going to be running high speeds anyway, so it's not really a big deal. But yeah, this is freaking auto timings. Like, I do have, admittedly, I only have one video about Samsung memory with Ryzen, I think. But you should go watch that. And that should give you some idea of what the timings, you know, should maybe look like instead of, well, this. But if you don't really want to do any work, then, like, you could just raise the TREFI and that would help a bit. But yeah, like, I don't get the logic of, like, submitting freaking XMP and Expo profiles. Like, what do you think I'm going to tell you? That it's good? That's not a submission, but okay, it's a super chat, so I'll read it, I guess. So, Silver Fox, been trying to undervolt my 14700K Z790 ASRock Nova, both with V-core offset and ACDC load line. P-core's at 48, E-core's at 36. For some reason, V-core is always higher than vid under load and hardware info. Is this bad? You probably don't, like, that. Does that board have a V-core sensor that actually measures the voltage at the silicon, or is it just off of the CPU socket? Also, AC and DC load line are used for calibrating the vid reading against the actual like power delivery behavior. Okay, actually no. So, man, see, if Intel had sensible power delivery practices, this wouldn't be an issue. But basically, your voltage readings, like how your vid reading compares to your core voltage readings, depends on your load line settings actually matching the behavior of the motherboard. And that's assuming that the V-core sensor you're looking at is actually measuring the voltage at the silicon and not on the motherboard's PCB. Because, yeah, like, Intel CPUs just lack the capability to ask the voltage regulator what the output voltage is. To be fair, that puts them on par with NVIDIA GPUs, but NVIDIA doesn't let you play with your power delivery, so, you know. NVIDIA GPUs don't need to know what the voltage is. So, yeah, I don't really have a fix for that because basically without the system in hand, I don't know what the board is doing. Anyway, next submission, we've got a Z790 Phantom Gaming Riptide. Okay, let's open this in a new tab, and it's running 6650. Is this like 12th gen or something, or what? No, it's a 14900 KS. Why do people buy this CPU? I don't understand. Like, it's so overpriced. And this is Hynix. Why is your TRFC so loose? This isn't 24 gigabit, is it? What capacity are these memory sticks? I mean, I'm going to assume that you just couldn't get higher memory speeds to work, and quite frankly, it's an Intel CPU, so I don't know how to get higher memory speeds to work either. But anyway, so 32, 40, 40, 32, 32. Okay, no, this is going to be a die. Yeah, so why is that TRFC so loose? TRD SG at 10, that really shouldn't be necessary at 6650. TRD DG4, okay, fair enough. TWR 19, yeah, like I can understand not bothering to like tune that. Like it doesn't like you can generally tighten it a lot, but it also doesn't affect performance that much. So though I wonder why your TWR pre and your TWR PDEN aren't similar. Because like I'm pretty sure like on auto the board would probably set them to kind of the same thing. And here they very much aren't. Anyway, TFall 16, cool. TCK4, CWL 12. Oh, right, Hynix things. Yeah, like the thing is on AMD you don't get to play with cast write latency, but like Hynix memory chips are really, really good at write timings for some reason. So yeah, I guess maybe your TWR might even be limited by the cast write latency, which I think cast write latency would take priority over TWR. Because there's like a equation that to calculate from like write to pre-charge, and then like TCWL, like you can calculate TWR from that because the TWR doesn't actually exist as a register on Intel CPUs. Anyway, read to read same group 14, read to read different group 8. Yep. WR10A, cool. Your read to write could probably go like 2 ticks lower. And then write to read 58 and 44. Yeah, that's sensible. So, yeah, like timings look fine. I'm surprised the TRFC isn't lower because as far as I can tell, this isn't 24 gigabit. And if this is 16 gigabit, you should be able to run lower TRFC. Though with your refresh interval set to 65,000, that's really not going to make much of a difference. So not really like a priority to go fix that, in my opinion. But yeah, this looks like timing-wise, this looks good. And if you want to like run higher clocks, well, I can't help you with that. So that's my thoughts on that. Anyway, moving on. We've got a Threadripper setup. 7970X running 6600 with 192 gigs of memory. So that's dual rank? Maybe? Is it? 48 gig sticks. Yeah, so that is dual rank. Quad channel, I'm assuming. Yeah, because it's the TRX 50, isn't it? So 34, 40, 40, 40, 48, 8, TRC 88. And 6600, you should be able to run lower TRC. Also, fun fact, Threadripper's memory controller is better than mainstream Ryzen. So, like, running 6600 in one-to-one mode is, like, a thing that you don't get to do with regular, like, with the Ryzen CPUs, because the consumer Ryzen CPUs, like, the I/O die on them is just not good. And I don't think 9000 series is going to change anything about it, or change much about it. Like, I don't think that we're suddenly going to see 3300 UCLK working on most CPUs. But anyway, so I would expect that you'd be able to run somewhat lower TRC than this at 6600 though. TRDS 8, TRDL 16, this is unnecessary. Like, you shouldn't... Yeah, I can't see any reason that you'd have to run TRDL at 16. TFall 32, yeah, cool. Like, I would think this would be like 8, 12, 32 is what I would probably try to run. WTRS 816, this can go lower. Like, I would try like 416. TWR 48, that's minimized. TRFC 725. At 6600, you should be able to lower that a bit more. Is TREFI limited to 32,000? I don't know. I don't, like, I don't have a Threadripper. Then again, if your DIMs are running hot, then running the TREFI a bit, like, not, like, slamming the TREFI is probably a good idea. Now, why your right-to-right SCL is at 16, I have no idea. Like, why aren't these just 8-8? Like, honestly, I would go, like, I would try 4-4 for the SCLs, but, like, at a minimum, I would try 8-8. Unless there's something weird about registered DIMs where they just... No, that doesn't make any sense, because this is, like, you have a different right-to-right timing over here, which is right-to-right SC, and that is literally 1, right? So if you're sending write commands to different bank groups... those don't have any delay between them, but if you're sending write commands to the same bank group, you have 16 cycle gaps in between those commands, and it's just like, but why? So, yeah, like, I'd definitely try to tighten that. RTP should be able to go lower. I am not aware of any reason why being registered would make RTP worse. Compared to just like the unregistered DIMs. TRD WR16, TWRD 8. I would think you should be able to run WRD much lower than this. And then since you're on dual rank, I mean, I'd probably try to run like 6-6-8-8 for the dual rank timings, but honestly, leaving them at 8-8-8-8 is probably just fine. Like, I don't think that'll make much of a difference to performance. Because, like, your right-to-right isn't going to get lower there. But yeah, like, why right-to-right? Like, if your right-to-right to a different memory stick or a different rank is literally lower than your right to its, like, same bank group, like, just 8. Like, I don't know why it's not 8. Yeah. Also, that is a lot of CPU VDD IO, which is interesting. Like, I don't know if that's actually necessary. I don't have any Threadripper boards or Threadripper CPUs, so I don't know how that memory controller behaves in terms of voltages, but, yeah. Yeah, but honestly, like, I mean, the main things I would change is TRDL and WRSCL, because, like, that just doesn't make sense to me that those are so freaking loose when everything else is, like, relatively tight. So yeah, that's my thoughts on that. Let's grab another submission. Right. We have a Ryzen 5600 on a Tough Gaming B450M Pro Dash Pro 2 running DDR4 3866. Damn. It's not often that you see... Does this not throw WHEA errors? Because, like, that is usually the problem with 5000 series, is, like, a lot... Like, basically any 5000 series CPU will boot FCLKs higher than 1900. Very few of them will run it without errors. Yeah, if this works, like, that's cool. And we've got dual rank, apparently. This is really dialed in. Like, it's not, like, the primary timings are bad, because I'm assuming this is some kind of Hynix, yeah. Like, everything else is actually, like, yeah, like, dialed, because 16, 8, 22, 20, 21, TRC 58, like, those are just Hynix things, like, it's not going to get better than that. TRDSNL 4-4, TFall 16, WTRS 2 and 8, nice. Or like WTRs 2 and 8, nice. TWR 10, TRFC 464. So that's like really tight. So which is also probably like why I'm like, oh, this is Hynix. Because if this was Micron, that would be looser probably. SCL's at 2.2, TCWL 12, RTP 6. Yeah, this is, and then even the dual rank timings were at like 4.466. So this is dialed. This is really cool. Yeah, because it's like I'm mainly impressed because it's not just generic B-die timings at 3800 or 3733. Um, so yeah, like the main thing I'm wondering about is like is the FCLK actually being fully stable at 1933? But like I guess it could be. I like the thing is I've still not had like I admittedly I only have two 5000 series like CPUs. Um so I don't really have a big sample size, but neither of my chips are stable above 1900 FCLK. Um that being a 5950X and a 5700X 3D. So yeah. But like I know that those CPUs exist. I just don't have one of those. So yeah. Anyway, oh, we've got more super chats, so let's just get through those. Man. Okay, so we've got a 5600X. We also have some comments here. 1.4 volts, I have no idea what I'm doing. He didn't even say what 1.4 volts. VCore, SOC? Like, if you're at 1.4 SOC, yeah, you do need help. TRFC auto, I don't know a nice number to punch in. Any number feels like Jesus take the wheel. Yeah, it's like it's TRFC. It, like, doesn't really matter. Command drive strength 24, 1T, GDM enabled, TCL can be 16, but memvolt needs 1.45. Yeah, that's just how cast latency works. You need more voltage to run less cast latency. TRC, DRD, default 22, anything else equals no post. Yep, that sounds like a lot of generic DDR4 memory chips. RP, default 22, anything else no post. Yeah, that's pretty typical. TWR10, Prime 95 starts erroring. Cool. TCWL 16, blue screen. This would probably get better if you applied more voltage. SOC 0.95 volts. What? Why are you, why would, well, yeah, like if you set your SOC voltage too low, it causes errors. Like, it's just like, it's, okay, so evidently spent a whole bunch of time minimizing SOC voltage for some reason. Oh, this is DJR, isn't it? Yeah, because that's a G-Skill 4018. That's going to be DJR. Or maybe CJR. Probably DJR, though. But yeah, 18, 8, 22. Bad DJR at that. Because, yeah, 3800. Oh, you have gear down mode disabled and command rate 1T. So that's nice, at least. TRC 43, so that's pretty tight. And then TRD's 44. That's, like, weirdly tight for Hynix. But, like, it's not, well, the TRFC is awful, and that could be lower. Like, you could, like, wait, is this, oh, wait, no, this is 16 gigabit single rank. Unless this is lying. In which case, yeah, I don't know what TRFC. Just go in, like, steps of 50 until it stops working. That's usually my approach with TRFC, is just, like, lower it by 50 or, like, 44 or something, right? Like, and just keep lowering it until it stops working. Like, at some point, it'll completely stop posting, so obviously that's never going to be stable. So then raise it up, like, you know, like, I wouldn't bother trying to run a TRFC that's, like, barely above being able to post, because if it's barely able to post, it's not going to be stable in a stress test. So maybe, like, I don't know, 30, like, I would try, like, 30 cycles above the minimum thing that posts, and then, like, check and that'll probably pass a stress test. And if it doesn't, raise it a bit more by, like, 10 or 20 or something. And anyway, TRD, TRDL, TFall 4416, so that's all good. WTR is 48, cool. TWR 12, this could probably, like, I think if you ran more voltage, that would probably get lower. SCL's at 44. Or actually, it might just be a limitation of the 16 gigabit Hynix chips. I don't know. I've not, yeah. Oh, no, I've had 16 gigabit Hynix chips, but the only ones I've had are, like, really early ones, and they're really bad. I've got, like, 16 gigabit JJR or something. Anyway, SCL's at 4.4, good. TCWL 18. Wait, you're at TCL 18. Okay, yeah, so that would go lower if you had more voltage. RTP at 10, that would probably get lower if you had more voltage. And TRDWR 8. Cool. So, yeah, there's not really anything noteworthy about this. Like, this is just like Hynix things. Like, yeah. Anyway, next submission. Oh my god, there's so many super chats. Why isn't this one working? How does this happen? Everything was going so well. Wait. Why is there not supposed what? Dahelta R with the Hynix MFR sub. Yeah, that one isn't working. I like I don't like maybe try post a full link or something. Cause yeah, I can't get that one to work. And don't super chat it. Oh no. I don't have like a way to make it like auto notify me if you send a new submission in. Right. Okay, well, I'll just grab the next super chat in line unless... Oh, wait, no, you already posted another one. Okay, I'll just grab that. Try to keep things in order. Okay, this one worked. Cool. We've got, like, almost 2 hours of Y-Cruncher on a 1600X. I mean, on a Ryzen 1600. With not B-die. Yeah, no, this is Micron? No. Yeah, probably Micron, because it's a Corsair kit, and the TRFC is horrible. So, 14, 10, 16, 17, 23, 57. Yeah, so that looks very Micron. And pretty, like, I mean... With Micron memory chips, you should actually be able to push higher memory speeds than 3200 on 1600 series. Like, I've seen some people manage, like, 3600, 3800 with Micron chips on first gen. Though that's hard, right? That is quite hard to do. So, but I would try like there's a 33-33 ratio, there's a 3400 ratio if I remember correctly, or a 3466. I would try those. Like I would loosen the primaries and try to see if those work because with first gen, like your FCLK is tied to your memory speed, right? So more memory speed, more better. So also it's worth noting that first gen Ryzen is technically like your 1600 is 3 core clusters. So even though you have like a monolithic CPU, your like core to core communication from like core 0 to core 4 is actually limited by FCLK, right? So with first gen Ryzen, you really want to try push the memory speed as high as possible. And if you've got Micron memory chips, that should be very doable as long as your like timings are loose enough. And they shouldn't be like proportionally, they should be roughly the same. So it's not like you're going to have more latency. If anything, the latency is going to get lower if you're able to run like 30. Like right now, you're at like 3214. You should be able to run like 3315 or 3416, I think. And your latency should basically get lower just because the FCLK is getting faster. But anyway, like for 3200, your primaries look fine. TRDs look good, TFAW good, WTR 410, TWR 12, yep, that's all good. TRFC 560, so that's pretty close to minimized jazz. You'll have to probably, like, if you want to push higher memory speeds, you'll probably have to lower the loosen TRFC. I'm not sure which micron this is, because there are, like, there's the good 8 gigabit, right, which is like the E-die, but there's also a bunch of bad 8 gigabit memory chips. Wait, you guys can't see the full window. This is a bit of an issue. There. And then SCL's 4-4, that's good. Cast write latency 14, cool. RTP 8, cool. And then this is single rank, so yeah, everything else is fine. So yeah, this looks good. Also, you can push the SoC voltage for higher memory speed. Like, you're at 1.06, like, you can go all the way up to, like, 1.2 for SoC voltage to try get higher memory speeds working. And also with first gen... Actually, 60 ohm proc ODT is probably optimal, but that is something that might be worth messing with. Actually, it can vary somewhat by motherboard. But yeah, like, you might want to experiment, like, to get higher speeds working, you might want to experiment with, like, proc ODT. Anyway, so, next submission. We've got someone with too many monitor pixels and a 13 Apex. Wait, is this an 11th gen or no, this is a 10900KF, the last good Intel CPU. So, we've got 4400 at flat 17s. Is this single rank or dual rank? Okay, this is dual rank. Yeah, so man, this is also a good one. What kind of system agent voltage does this need? CPU VCCSA 1.37. Man, I'm pretty sure my 10900K wouldn't even post at 4400 with dual rank. And 1.37 volts SA. But yeah, so this is really good. Oh, and we can make it really big too. But yeah, so 4400, 17, 17, 1734, 2T. Which the 2T I think is just like, if you're running dual rank at this kind of speed, I don't think you can get like escape that. 4.4, 380, that is well, your TREFI is so high that, like, yeah, okay, fair enough. It doesn't really matter if the TRFC was lower. TWR 12, RTP 12, TFAL 16, that's all good. And then the tertiaries, we got 7, 4, 11, 11, 7, 4, 28, 24, 6, 0, 11, 0. Yeah, so you've set all the different dim timings to 0. And then 7, 7. Yeah, so this is really, really tight. Like, this is dialed. What kind of Geekbench does this get? Yeah, almost 10,000 points, which, like, that's high. Especially because, like, so the thing is, Geekbench is really, like, a memory bandwidth test in terms of the score, and it's not very, random. So single rank is generally better for pushing really high Geekbench numbers, because you can just run higher clocks, even though in, like, real world workloads, single rank gets kind of wrecked by dual rank. So yeah, and we've got under 40 nanoseconds of latency. I wonder, did you mess with, like, optimizing the RTLs at all? Because we obviously can't see them here, but that is, like, potentially, like, if you want to do one more thing, you could, like, try tweak the RTLs a bit. But yeah, this is like, this is a really nice CPU. Really nice settings. Anyway, moving on to the next submission. We got another Intel system. Honestly, I prefer, like, as much as why is this so low pixel count? What are you on, like, a 480p monitor or something? Also, what is this font? Why would you do this? Anyway, we've got an Apex running 8266. So yes, we've got more things that I can't do. No sign of any stability test for this, so I guess we get to wonder about, you know, how much like, this could just be bench stable. I'm leaning towards this being bench stable, because I am relatively certain. Like, I'm 262 TREFI. As far as I know, the only way you're getting that to not randomly crash is if you run the memory sticks at like 20 degrees or something. Like, you need to keep the memory temperature like really, really low to be able to run TREFI 262,000 long term. Um, so yeah, and then all the other timings here, like the read to read same group is a freaking 13. This has got to be also at like crazy voltages. I mean, yeah, no, like it's TCL 34. Wait, it says 1.56. No, I refuse to believe that you're doing 8266 at 34 at 1.56. Like, unless you had like a water chiller and these memory sticks were at like below 0 degrees, then I'd believe it. But at ambient, hell no. But anyway, so yeah, 34, 47, 44, 59 to WR12, 640, 420. Oh, right, 24 gigabit. Okay, that makes sense that the TRFC2 is so loose. TRDLNS at 12.8, TFall 32. Yeah, like the timings here are like this is slammed. This is absolutely slammed. Like this is like these are either like some of the best memory sticks. This is 24 gigabit. Like 24 gigabit doesn't even do good TCL at like in general. So yeah, I do not believe that voltage reading at all. There is no way this is at 1.56, or if it is at 1.56, these memory sticks are at like minus 20 degrees or something, because there's no other way I could see TCL 34 working at 8266 unless you literally went and binned like hundreds of sticks to find this. Because this is insane. Or it's really like this. The thing is, like 34 at 8266 on a lot of memory sticks, like that's not even gonna post. Like this isn't even like, oh, it's probably unstable. It's just like, wait, unless you're if I remember correctly, if you change TCL, does it crash or does it just not do anything? Can't remember because you can tweak cast latency in OS, but there's like a bug with it. Like it either causes a crash or you can set it arbitrarily low without it actually affecting anything on Intel CPUs. And it's been a while since I've done that, so I don't remember which it is. I think cast write latency, if you change cast write latency in OS, it locks the system up. And if you change cast latency in OS, I think it does nothing. So you could potentially set like, so you might be doing that. Yeah, I'd believe that if you set your cast latency after the system posted, then it's just not like it's just not real. Um, because yeah, if this isn't like if this isn't some kind of trickery, then these memory sticks either have to be the greatest silicon Hynix, like some of the like top 0.1% or something, or at very low temperatures. um. Anyway, next super chat. Z690 Edge Wi-Fi with a 13700K running DDR4 4000 and 16, 16, 16, 36. You can lower your TRAS. I mean, it's not going to make a huge difference, but you could lower it. 16 TRFC 300. You could probably run lower TWR as well. RDs, that's another one of those, like, won't really make a massive difference, but you could lower it. RDs at 4.4, WTRL and S at 8.3, RTP8, TFall 16, cool, because, yeah, TWR, SG, and DGR 28 and 3. Read to read same group 8. I'm pretty sure you should be able to run that at 7, shouldn't it? And for DDR4, you can run odd timings. Like, that's like a DDR5 thing that you can't run odd timings. And anyway, so 8, 4, 7, 7, 12, 12, 12, 12. So that's all good. Now, so this is not super tight. This is like pretty. Yeah, this is like generic B-die, dual rank B-die things with 13th gen. So nothing super crazy there. And there was a more. VDDQ is a bit high, so I could get better RTLs. Okay. It passes Y Cruncher 3 hours of 60 VT3 with only 1.23 VDDQ, 1.2 SA. I like 77, 73 over 70. Yeah, generally having your RTLs the same, like, can have like a slight latency benefit sometimes. Can't pass Y Cruncher at 4133 and 4200. Can't pass test mem 5. But your voltages are like super low, so that's probably why it doesn't work at 4133. Here's some CPU abuse below. What, you mean Y Cruncher? Y Cruncher isn't even anywhere near as hot as Prime 95 small FFT, so I don't see that how like why you would consider that CPU abuse. Then again, with 13th gen Intel CPUs, turning them on is arguably abuse. Anyway, yeah, so this looks like sensible. Very, very sensible. Let's go. Next super chat. We got a Z790 Hero. Running 6800, yeah, because it's a 4-dimmer. And if you want high memory speeds, you don't buy a 4-dimmer. The fact that DDR5 officially supports multiple memory sticks on a memory channel is, in my opinion, a design flaw. PCB destroyer for 6 hours, multiple runs, not a perfect test, but passed each one. I mean, you're at 6800. If this wasn't, like, if 6800 wasn't stable, I'd be very, like, even I would be concerned. Because generally 6800 is, like, that's where, like, that usually works, in my experience. Like, 6800, especially on single rank, usually shouldn't cause any massive problems with Intel CPUs. Now, once you go past 6800, things start getting progressively more and more annoying. And like if your depending on the motherboard, like even like 7000 can be a massive pain. So anyway, let's take a. This is really loose, like really, really, really loose. Why? 34, 45, 45, 56. Yeah, what? You're at 1.4. Like, I mean, the cast latency isn't going to get lower, but TRCD at 45 at 6800, that's ridiculous. That's like, there are literally XMP memory kits that come with TRCD 45 at like 7200, and they're not even tight. So, like, your TRCD, you can lower that. TRAS, you can lower that. TWR, this is literally on auto. TRFC2 and per bank, well, at least you tune those in TREFI, I guess. TRDL and S, okay, 8, fair enough. TFAW32, yep, cool. RTP16, and then why is TRDSG at 18? Like, you're at 6800, like, maybe if you were at 8000, 18 would make sense, but at 6800, you should honestly be able to even run, like, 14 potentially. I really don't know why that isn't at least 16. 18 is really unnecessarily loose. Read to write 2020, yeah, this can be lower as well. Write to read 6452, this is really high as well. But you did go through and set all of your different rank and different dim timings to 1. That was a productive use of time, wasn't it? Left all the tertiaries that actually matter on like this might actually be auto for this motherboard at 6800. So yeah, like 16, These should 18. These might even do 16 at 6800. I'm not 100% certain, but like I would basically like, yeah, like I'd take 2 ticks off of that, 2 ticks off of this, and also the right to write same group, and then right to read. Um, this like same group can probably go below 60, and different group can definitely like I would probably try like 44 or lower even for different group right to read. Because yeah, that is really loose. Um, and then your primaries are just horrendous, and I don't like this is like these are primaries like your memory kit's at 7200. Like why? You're at 6800. You could probably lower TRCD to 40 or like 41 or something. Um, so yeah. I mean, you did at least set like like the most important timings, that being TREFI and TRFC. Oh, and yeah, TWR can be also a lot lower. Um, but you'll want to like set TWR. Well, actually, you're on an ASUS board, so setting TWR directly shouldn't cause issues. Samsung A die. Let's go to the next super chat. Apparently, Samsung A die. Oh no. Okay, no, it works. Ugh. Well, it's a good thing that this is a unicorn, because it's a bad unicorn. 3600, 18, 20, 20. This is just like B die, isn't it? I mean, C die. Um, yeah, actually, it's slightly better than C die, maybe. 18, 20, 20, 20, 40, 76, 6. No, it's worse. Wait, did you even try to tune this? Because this looks like auto timings. Like 6, 9, 38, that looks auto. Even freaking C die does 4, 4, 16. At least my C die does. WTRs, yeah, this is all auto. SCL's at 5.5. This is auto. What do you want me to react to it? Like here's the thing about auto timings. They're the same for every memory chip. That's like because the way the auto timings generally work is they just take JDEC like 3200 timings and then they scale them up by the difference between 3600 and 3200, right? So if at 3200 the JDEC spec for say TRDS is 4, which I'm pretty sure it is, or 5, then at 3600 you end up at 6. Yeah. So I don't like, and the thing is, I've never worked with ADI, so I don't even really know what to tell you to try here, other than like, try the usual thing, like try 4.4, like, well, maybe not 4.4, but like try like 4.6, or 4, like, like tighten things. Like, actually try to tighten this. Like, you're just gonna have to go through and like try to tighten a bunch of timings. I would probably start with like TRDS, L, TFAW, the SCLs, TRC, because that's kind of like low. Like having massive TRC is bad for performance. TRFC though, well, I'm not sure if a gigabit A die is older than B die, chances are it'll actually do lower TRFC. It'll do low TRFC. If it's newer than B die, it probably does worse TRFC. But I'm not sure, because yeah, yeah, I'm not sure which way this is gonna go. And we have some X299 up next. That should be interesting. With a Micron, Crucial Ballistics, dual rank. Okay. And I'll get my tabs under control. Okay, so 64 gigs total. What board? X299 Aorus Master. Huh. That was, well, yeah, okay. I mean, I was like, I just assumed that it was going to be an Asus board because, like, Asus sells the most motherboards, but interesting to see not an Asus motherboard. 10940X at 5.1 gigahertz. Man, the 10th gen CPUs made the silicon so much better. 3.2 gigahertz ring. And been stable for around 6 months. I used it as a server PC, so it's 24/7 uptime. Cool. So 3733? Yeah, 3733. 15, 19, 17, 38. Yeah, that's just Micron things. I wonder if no, because on AMD you have a separate TRC timing, so you can adjust that. But on Intel you don't. So your TRAS sets your TRC. Command rate 2T, yeah, I think that's just going to be a requirement with dual rank. 4.4, 16 TFall, TRFC 630, and refresh interval 32,000. That's maxed out. You can't set it higher than that on, like TREFI doesn't go higher than that on X299. And the TRFC is just like Micron things. TWR 18, that could probably go a bit lower. RTP 8, yep, fair enough. WTR 2, WTRL 12. You could probably run that lower, WTRL. TCK could probably go lower, though that one isn't super important for performance. Write latency 12, that's cool. So, yeah, and then read to read different rank 3, read to read different dim 1. This is 16 gig dims? Yes. So that makes sense. Read to write 6. The thing is, I don't know what the tertiaries for X299 should look like. Now this looks fine to me in terms of tertiaries. Because this is like a read to write transition, and that usually takes longer. And then like write to read, man, wait, that's DD. So okay, write to read different rank. Yeah, and write to write different rank. Okay, yeah, that makes sense. And then TCCDL2, TCCDL2, yeah, and then read to read different S. What? I don't know what the DS is supposed to stand for. I have to look that up. Man, and it's really annoying to look up the like X299 CPUs for some reason. Like the Intel HEDT, getting the data sheets for those sucks. Because the naming conventions for them are all like the mainstream CPUs, you just like look up like 13th gen and you get what you want. But with the server CPUs, you have to like search for like Xeon data sheets, and the naming scheme for the Xeons is horrendous. But yeah, I don't really see anything like if you've manually tried to tighten everything there is, then like I don't see anything that's like that it like looks weird to me here. So anyway, next submission. Ooh, we've got some 4300 on 13th gen DDR4. And so let's go through. SA 1.3, VDDQ 1.35. So this is a good CPU that you can run 4300 at like reasonable voltages. DRAM 1.5. Yep, that's pretty normal. This is now BDI 13900K. Yeah, can't do 4400. Yeah, the most CPUs don't do 4400. Honestly, I'd say most CPUs can't even do 4300 because I still don't have a like LGA 1700 CPU that boots 4300. Wait, boots? No, yeah, like well, I don't think I tried my, no, I tried my 13600K. That's worse than my 13900K. I don't, I might not have tried the 14900K I have, but even my 13900K is like worse than my 12600K because memory controllers don't get binned as part of the manufacturing process. So whatever, like it does, like you can get like i5s having better memory controllers than i9s is like completely normal. Except maybe the KS. I'm not sure. Anyway, let's take a look at this. So 16, 16, 16, 24, 2T. Yep, so pretty standard primary timings for B-die. Actually, on the better end of silicon quality for B-die, because this is at 4300 and it's just 1.5 volts on the memory. Like there's kits out there where you would need more than 1.5 volts to run the like flat 16s. And this is dual rank. Okay. So 12, 301, cool. 4, 4, 16, 8, 4, yep, RTP6, cool, TCWL 14, refresh interval, another random non-flat 65,000 number, that's interesting, but it is still basically 65,000, so, yep, TRD SG7477, 12, 12, 12, 12, 12, 28, 24, 5, 5, and then 74777, cool, yep. This is like pretty standard B-die tertiaries. A bit surprised by the 5-5 for the right to read. Then again, I don't think I've ever tried to push right to read different rank and different dim as like low as possible. Is there anything else? 1 year ago, old timings, same everything was stable to 4000 CL15. But can't do 4000 CL14 or command rate 1. I mean, CL14, you would probably need way more memory voltage. Right? Like 1.6 memory. Like, yeah, like 1.55 or more memory voltage to get CL14 working at 4000. But generally speaking, it's better to prioritize memory speed rather than, like, especially cast latency. Like, it just doesn't matter that much. Wait, this is also 4300. Oh, this is like stress tests, I guess. No, this is a stress test. Oh, lower TRFC on this. I mean, that doesn't really make much of a difference. It's like what? Like, and then everything else is the same. Yeah, so, oh, and TRAS is looser. But yeah, so basically the same settings is what we're looking at right now. Anyway, so next submission. The chat just jumped for me. So does that mean I missed a whole bunch of, super chats? It looks like I only, okay, there's one. Good. And I've been, okay, we're at 1 hour and 30 minutes. I don't really feel like streaming for 2 hours today. So, I mean, for 3 hours today. So at 2 hours, that'll be the end. So, just a warning, because you have like 30 minutes, to like force your submission in. So, oh no, why is there so much hardware info? Okay, 5900X on a Strix B550E motherboard. No, I had the XE, not the E. Yeah, I really hated that board. Anyway, so 16.8, mostly because it was like mediocre at memory overclocking, which means it maxed out at like 3866 for dual rank, which yeah. And for single rank it maxed out at like 4600, which yeah, not great. So it's fine for a daily board, but yeah, like I wanted it for benching and it was not viable for benching. Anyway, 16.8, 16.4, 28, 42, so pretty typical B-die timings on the weaker end of the silicon quality spectrum, unless this is at like very low memory voltage, which should be somewhere in here. Except it's not labeled, so I can't find it. So that's fun. But yeah, if this is at like 1.45, then this is pretty typical. If it's at 1.5 or higher, then this is pretty bad in terms of like memory silicon quality. TRDS L4416, cool. WTR 410, cool. TLUR 10, cool. TRFC 288, and then SCL's at 44. And then dual rank timings also sat to like 4 and 6. Cool. At 1.1 volts SOC. I mean, you could maybe try lower the SCLs a bit, but there's really nothing I would change about this. Like, yeah. Like, if your sticks don't do lower CAS latency and lower TRCD, and you don't want to raise the memory voltage, then, like, this is what you're just stuck with this. There's nothing you can really change. So yeah, this looks like pretty generic B-die timings with a 5900X. That's that. So so RTLs on like Intel are weird. You can try maybe like messing with the memory controller voltages to see if that brings them in line, but chances are they're just never going to line up on their own. And like just, you can just learn them. I mean, I usually just leave them alone. I just like, especially on like 12th gen, 13th gen, I just don't concern myself with them because I haven't figured out how to, like on older Intel CPUs, like 10th gen and older, uh, on there's like on some motherboards you can manually tune them, but like 12th gen forward, it's just like the only thing I do about RTLs is there's like an option in the BIOS to turn on RTL training. You turn that on, and your RTLs get a bit tighter, ideally, and your stability ideally doesn't get worse. So yeah. Anyway, let's go through some more submissions. And I'm just going to leave, like, I'm just going to continue off from where the last super chat was. So, yeah. Oh, and we have another super chat and another one. Okay, well, I already grabbed a different submission, so that one's going first. Like, you're after this one. Anyway, what do we have here? Looks like another 5900X running 4,000. And B550 Aorus Pro V2. Dual rank. Oh, this is 4x8. Older, not quite stable. Newer, looser, still work in progress. Still 4,000 though. Do we have the error readout at the bottom here? No. Because that's the thing with like running high FCLK on 5000 series is it won't necessarily crash stress test. It'll just silently produce like hardware errors. So 16, 12, 16, 16, 32, 48. Yeah, so pretty standard V-die timings for the primaries. TRD SNL at 6, 8. And TFAW 24. Like honestly, like I'm not 100% certain about this, but I would probably lower the clocks and try to run lower TRDs and TFAW. Yeah. Yeah, because even on like different group accesses, you're gonna be inserting like 2 clock cycles in between the operations. WTRS 6, WTRL 14. This is just loose. Like at 4,000, like it might be necessary, but like I'm like this is TWR 14, TRFC 270, that's tight, but SCLs are 4.4, TCWL 16, RTP 8, and then your like dual rank timings are also like 5577. Like honestly, I wonder if this isn't like because like a lot of your secondaries and tertiaries are just like looser than they would like you should be able to run them at like somewhat lower at 3800. And so I am wondering, like, maybe the FCLK increase would offset the weaker timings, but I do wonder if 3800 with, like, tighter timings wouldn't just be faster. Yeah. I do wonder about that. Because it could be. Though I also wonder if, like, you couldn't just run because the thing is from, like, the memory itself really shouldn't have issues running, like, TRDS4 at 4000. Like, that shouldn't be a problem. And your WTRL and WTRS are, like, really loose even for 4000. TFAW is also really loose for 4000. Like, if, like, I kind of doubt that these settings are, like, that these should be necessary because of the memory. They might be necessary because of the memory controller, in which case, yeah, I'd probably just back off the memory speed. Because these timings are just not great. And it makes me wonder if, like, you wouldn't be better off at lower memory speeds with better timings. Older, not quite stable. Newer, looser, still a work in progress. Yeah, like... Also, you never had tight dual rank timings. Like, you're always at 5577 instead of 4466. You loosened just like everything, didn't you? Yeah, it really looks like you just like didn't know what was causing the instability, so you just loosened everything. Except TRFC for some reason. um Like, my approach is, like, if you need to loosen out TRRDS, or, yeah, if you need to loosen TRRDS and TFAW to maintain stability, it ain't worth it. Anyway, let's go to the super chats now. Mr. Buildzoid, what should I do if I have a EVGA Z790 board that, given the Intel issues? EVGA support has not been any help. Well, EVGA doesn't have a BIOS department anymore, so... Yeah, like, I'm not surprised that they can't help you. I guess, like, manually try to, like, yeah, try to, like, manually set the CPU up. I'm not even sure if you have all of the options on the EVGA boards for doing that. Because EVGA tends to hide a lot of, like, extra settings. Couldn't get 3800 C14 with 4 sticks. Yeah, but cast latency doesn't matter. It's not important. Like 3816 with like tight sub timings is still better than 3814. Doesn't give IVR limits. Yeah, like I would assume it doesn't. Yeah. I mean, what you could do is like set the AC load line. Like you could set the VRM to like 0 V droop or close to 0 V droop, and then set the AC load line to 0. That tends to help with the max voltage quite a bit. Anyway, yeah, moving on to the next super chat. How much time do we have left? Okay, 15 more minutes. What? Why does it warn me about this being over 18? What are your timings? There's some not safe for work timings. So, Why? Why? Why could you not just take a new screenshot? But okay, whatever. 13600K at 4133, 1.45 volts. Well, that explains why 14 doesn't work. Because yeah, 1.45 volts and 4133 doing CL14 is really optimistic. SA 1.25 VDDQ 1.33. And we got so 16, 16, 16, 28. Cool. TRFC 280. Cool. Refresh interval at over 100,000. Neat. TWR 12, WTR 4, WTRL 8, yeah, TRD 44, RTP 12, TFall 16. Man, what is up with like the timing order in all of these readout utilities? Like, why is TFall like the only one that does this correctly is Zen timings, where TFall is next to the TRRD timings. Everybody else has TFall just in the middle of freaking nowhere for reasons I will never understand. Anyway, TCWL 14, TCKE4, and then 7477, 7477, 12, 12, 12, 12, 12, 28, 24, 77. Cool. So pretty generic, like generic B-die tertiaries. And also some pretty tight RT. Oh, wait, the RTLs are looser once you set TCL to 16. So yeah. Yeah, no, this looks good. Yeah. Like, I don't know. Was there anything like, yeah, this just looks good. It looks like pretty standard B-die timings. Nice. TWR might go 10. What? Oh yeah, like RDWR might go lower than 12, but like it's not gonna make a huge difference. I kind of doubt it'll do 10. 11 might work though. Okay, let's grab another submission. Ooh, a 7600X. Not running 6000. Yay, running 6200. Like, this is one thing that bugs me. Is like, for some reason you have people who, it's like, with Ryzen, like, if you just run 6000, I can understand, okay? But the fact that there's, like, a lot of people who is like, no, I don't want 6000. I'm going to try 6400. And it's just like, you do realize that most CPUs don't do 6400. Why are you like this? There are other memory ratios. I mean, there's actually just one between 6000 and 6400, but like why don't you just try 6200? Anyway, so 6200 28 37 37 35. So this is going to be it's just 1.43 VDDQ. Good sticks. So 40, 75, 48, 20, 414. Yeah, this is nice. TWR 48. Apparently you can run like you could try TWRS WTRS at 2 apparently. TRFC 466, SCL's at 44, RTP 12, RDWR 16. And this is single rank, so we don't have to worry about the dual rank timings. Yeah, so that all looks really good. SoC voltage is actually really reasonable. This CPU might run 6400 at 1.3. I mean, I don't know that I'd spend a bunch of time like trying to get it to work, but like there's a decent chance that if you can run at 6200 at less than 1.2 volts, that you would be able to also run 6400 at 1.3. And then FCLK at 2200, and then yeah. Though if you go to 1.3 SoC, like your FCLK might get upset about that, as it tends to do. Also, yeah, refresh interval maxed out, and then my current settings. Oh, wait. I missed something, because my current settings are 6400. Wait, what? You're still doing that at 1.22? Dabbled, 6400, got it to run. 8 hours, no problem. Soon as I tried OCCT AVX2, it just fell apart. Or with long gaming sessions. I haven't tried SoC above 1.25 yet, or VDD-IO above 1.35 at 6400. Yeah, that might be worth trying, though. You're on an Asus board, so yeah, like try more VDD-IO, more SoC. I think more SoC is probably going to be more helpful than more VDDIO. It might also be worth trying to lower CLDO VDDP because having it really high isn't always the best. Wait, for 6400 you're in 2-to-1 mode. Do not. Absolutely do not. Yeah, do not, like UCLK, do not. No. Well, that explains the whole, like, wait, how are you running 6400 at 1.22? Yeah, because he's not running 6400 properly. He's running like half speed UCLK. No, absolutely do not. 2-to-1 mode is bad and should be avoided at all cost, unless you're gonna run like 7600 or higher, which your motherboard will probably not like. Yeah, in my experience with your motherboard, probably won't even post at 7600. So, yeah, I would just go right back down to that 6200 setup. That looked really good. Because if you need to, like, no, like 6400 with 2-to-1 mode is bad and should be avoided. So, wait, did I miss anything? No, but there is another super chat, so we'll do that. Can do 24 hours Karhu and VT3, but I've done that more than 3 times, so I'm too lazy to do that again. Yeah, no, that's fine. And we've got 82, 66, 34. Oh! That's the, like, no way in hell does this actually work. What are the memory temps? 30. Okay, well, that solves the TREFI. That doesn't explain the TCL. Like, at all. How many memory sticks did you go through? Or the, like, that doesn't explain how the TCL and the TRDSG are working. Like, yeah, they scale with temperature, but like 30 should be way too warm. Like, this is well into the territory of like this actually just won't post on most memory sticks in my experience. So like I don't get how this runs. Yeah, I don't get how you can have TCL 34 at 8266. Because like you literally can't cold boot these settings on most DIMMs. Like I don't think I have a single kit of RAM that would post with these settings. Unless they were like below 0. So like how many memory kits did you go through? Doesn't turn the PC off. No, my point is that even if the memory sticks were literally at room temperature because they weren't running and you tried to turn them on, they wouldn't, because the moment they tried to like do anything at TCL 34 at this kind of frequency, it would just not read. Yeah, this is Hynix chips, but this is way better than any Hynix chips I've ever seen. The memory sticks aren't going to degrade. Like, it's at 1.56. He's not at crazy voltages. Like, it just doesn't, like, this is like some freaking top 0.1% RAM right here. Like, I need more voltage than this to run 34 at fucking 8,000. Like, literally, I can't even run 34, like 8,000 CL34 to boot needs like 1.6 volts. And this is 266 mega. This is like 133 megahertz higher at less voltage and running a freaking stress test. And it's not even 16 gigabit. Like a die, you know, it'd be like, okay, but it's 24 gigabit and it's just like this RAM is not I refuse this RAM can't be real. What max temp? It's 30. It's, or like 32. Like it's just like it doesn't the temperature doesn't even matter though. Like this isn't in the realm of like this can like this isn't in the realm of like functional at room temp as far as I'm concerned. Unless you like bin hundreds of memory sticks. Real-time timing's enabled? Wait, where can you see that? Yeah, like that's the only way I could understand that TCL being at 34 is if he changed it after the system posted. Because as far as I know, you can set TCL to whatever you want after the system has booted up. But if this is real, this is some insane RAM, like absolutely insane. Like this is just like I can't believe that this works. Like it's like to you know like admittedly I don't bin memory kits because I don't like memory overclocking that much. But yeah, so like I don't really have a great reference for what the range of silicon quality for like 24 gigabit MDI is. But like how? So anyway, you win today's reacting to RAM timing stream because yeah, like I don't get how this works. Also, that TRD SG, that just like as far as I know, at 8,000, if you go below 16, it just doesn't run. How is this running? And that you can't change that one after you're in the OS. Like this one does vary with silicon quality a bit, so like yeah, this has to be just like insanely good memory sticks. Yeah, like TRD SG as far as like I'm like the TCL you can change that on the fly. Also, I just noticed the real-time timings. But the TRD SG like you can't like this one doesn't break. You can't cheat that one. Like if you set this in the operating system to 13, it will just like it'll just lock up at 8,000. Unless you have literally the best memory sticks ever made. Been like 10 sticks. No, like I like the TRDSG is like that to me is like yeah, this is just top bin memory sticks. Like you can't I mean, you could like Photoshop that, but like that's too much effort in my opinion. Like I don't think like if you go that far, you know what? Sure. You deserve to spread misinformation at that point, but I don't like yeah, like I don't bin memory kits, so that's how I never see stuff like this because you know, I'm not going to go buy 10 memory kits. Or I'm not even going to like ask for 10 freaking samples of memory kits. That's insane. That's absolutely insane. Like that SG, the read to read SG at freaking 13 is just like, oh my god. So anyway, let's move on to some other submissions. Okay, I'll just grab the first one that showed up. Two by 12? What? This exists now? Okay, see, this is more my kind of thing, like the SG at 16, you know? And this is at 7,200? But yeah, so 34, 44, 44, 56 to 640, 580, 12, 8, 24, 12, 11, 32, 32, 32,000 refresh interval. You could probably run higher refresh interval than that, unless your memory sticks are running insanely hot. But yeah, this just looks like 24 gigabit MDI, except like, because that's what this is like, this is the same 24 gigabit memory chips that you see on the 24 gig sticks. There's just half as many of them. And there is a slight performance penalty to that. It's not as bad as it was with DDR4, because you even like the cut down DDR5 sticks are not like, or it's not cut down, but like the X16 DDR5 memory chips, like with DDR4, you go from like 4 bank groups to 2, which is really bad. With DDR5, you go from 8 to 4, which sounds equally bad, but it's not as bad because you can still, like, the problem you run into going from 4 to 2 is that you only have 2 bank groups to interleave, and that's really hard to do because you only have 2 bank groups, whereas going from 8 to 4 is not that bad, right? Because you still have 4 bank groups to interleave. Whereas, so going from like 8, it's also why like dual rank DDR5 doesn't have some crazy performance advantage, because going from 8 to 16, just like, yeah, there's more bank groups to interleave, but it wasn't exactly difficult to get perfect interleaving with just 8 of them, right? So going up to 16 doesn't make your interleaving that, like it doesn't make your interleaving better, because it was already really good to begin with. So anyway, yeah, 34. So like primaries look like generic Hynix stuff at 7,200. Tertiaries look like generic Hynix stuff. This nice and safe timing to the insanity that we saw before. You could probably run lower write to read same group and different group, especially different group. Like I don't think there's any reason that would have to be at 50. And yeah. So anyway, so yeah, 12 gig DIMMs exist. They clock okay. Don't run 4 of them, because that would be dumb. And they time like your 24 gig DIMMs. So yeah, it's pretty normal. Got another submission in. Let's take a look at this. And these 390 Aorus Pro CF. Oh no. Yeah, Gigabyte Z390T topology was like, there's like a good version of it and there's a bad version of it, and the bad version is really bad. So I'm gonna guess this is the bad version because we're at 3,500. Latency's okay though, because like the 9th gen memory controller is actually pretty low latency, especially compared to like 13th or 14th. Well, really everything like 11th gen, 13th gen, 14th gen. Like that's the funny thing is like especially 12th gen and like 13th gen, 14th gen will absolutely destroy a 9th gen CPU in terms of like performance. But because of how the IDA latency test works, it'll tell you that 12th gen has more memory latency than 9th gen, which is just like, and this is why I don't really care about IDA latency numbers. Because it's completely devoid from, like, it just doesn't correlate with reality. Um, like, it's fine if you're comparing a 9th gen CPU against another 9th gen CPU, then the latency number, like, tells you if your, like, timings are lowering the latency. But if you compare, like, different CPU architectures, it's actually meaningless. But anyway, let's take a look at these timings. This is BDI, because this is 3500, 14, 14, 14, 28. 1T command rate. Yeah, I'm assuming if you went to 2T, you'd probably not be able to run a much higher frequency than this anyway, so that's a reasonable trade-off there. WR12, you could probably run that lower. TRFC 246, cool. TRD LNS at 6.4, TFAL 16. WTRLNS at 8.4, cool. RTP 6, TREFI 65,000. TCKE 6, and then 7, 4, 7, 7, 12, 12, 12. These could go lower. 26, 22. These could go lower. You're at 3,500. So, like, yeah, a lot of the tertiaries, when, like, if you see, like, a certain set of tertiaries working at 4,000, if you're at, like, 3,500, you can probably tighten that down because your frequency is so much lower. Unless you're running really low voltages, which you might be, because, like, CL14 at 3,500 isn't anything insane. Like, that'll probably work at, like, 1.4 volts. There's no voltage mentioned anywhere. But, yeah, also, you might... Does that... I don't remember if you could do that on the Gigabyte Z390 boards, but you could... There is a way... Yeah, I'm not sure, but you might be able to tighten your RTLs and IOLs, and that'll actually give you some extra bandwidth and latency. But I don't remember if that worked on Z390. It definitely worked on Z490 Gigabyte, but I'm not sure about Z390 Gigabyte. Because Gigabyte RTL tune, like, Gigabyte's, like, weird about, like, certain parts of the memory tuning. So that might not be possible. So, anyway. Let's keep going. Next submission. I'll just grab a random one at this point. I've completely lost track of where I am. Oh, we're at 2 hours now. So this will be the last one. And it doesn't work. I'll just grab a different one. There's DJR. Wait, there's a 4x32 MJR on a 20... Okay, that sounds more interesting. We'll grab that. I want to see what that looks like. So we got a 2990WX. Man, 32 cores these days doesn't even sound that insane anymore. And this is MJR, 128 gigs. Man, oh, dude, how long did this take to stress test? Because this is a 2nd gen. So the memory performance is horrendous. So this must, like, oh boy, this must have taken forever. Well, I guess that explains why it's at 3,200, because, yeah, I would not want to try to max this out. Because it would just, like, not be fun. At all. Ooh, on the X399 creation, cool board. I approve of that board. TCL15, TRC-DWR8, TRC-DRD19, RP17, TRAS42, TRC44, so that TRC isn't real. TRD-SNL at 4.5, TFAL 16, WTRS48, TWR, what? Is that some, like, massive weakness of MJR? Because I think you could run that lower, like, a lot lower, like a 12 or lower. TRFC 480, yeah, Hynix things, SCL's at 2.2, and you should probably tighten your dual rank timings. Yeah, like instead of 5.476 to 4.466. Other than that, this like looks pretty standard. Like, yeah, there's nothing really. RTP at 12. Yeah, this isn't anything. Like, it's not super tight. It's just kind of a ton of RAM. And then there's also a 5900X running generic B-die. Oh no, it's not generic B-die. It's another. You sir have one memory kit and you just move it from system to system, don't you? Wait, is the 5900X actually just faster than a 2990X even in multi-core? It is, isn't it? Because like 2000, like 5000 series is like a big jump. Okay, no, 5900X probably isn't a big enough jump. 5950X probably is, but yeah, because 12. I don't think the like per core performance uplift was big enough to make the 12 core beat the 32, but I think the 16 does. Anyway, so here we have much more reasonable, like much better looking timings. 16, 8, 20, 20, 42, 62. Yeah, so now TRC is actually real. TRD's at 4, 4, 16. TFall 16. Well, yeah, so you get the idea. 4, 4, 16. 5, 14. What? It was 4, 8 here. Does running 3800 make WTRS that much worse? I mean, WTRL that much worse? It's not impossible, but I just find that kind of surprising. Yeah, because going from 3200 to 3600, that's not even like a. That's disproportionate because you like your WTRL went up by more than 50%, and your memory speed did not go up by 50%. So this is probably looser than it needs to be. TWR is now slightly tighter. TRFC 550. Okay, I think that makes sense. And then SCL's at 4.4, and then your dual rank timings are also on freaking auto. You should tighten, like, if you care about performance, you should tighten them. I kind of suspect you don't care about performance. This is just like showing off. Hey, look, I can put 128 gigs of DDR4 into like a system where I would never want to have 128 gigs of DDR4. So, yeah. You know what? I'll do one more. And that one didn't work. Probably because I copied it wrong. Give me a second. Yeah, I copied it wrong. What? Oh, 4400 Viper Steels. 5600X is a failed 5900X, says 2 CCDs active in debug. Ooh, fun. And it runs 2000 FCLK. With, is this just, oh yeah, it's B-die. Not super tight, though. I guess the voltages are being very reasonable, or, no, you're at 1.6 volts on VDIM and you can only run 16, 17? What? You got really unlucky in the Silicon Lottery with that. Because that is, yeah, that is awful. Like 1.6 at 4000 should be enough to do like 15 or even 14. So yeah, that's really unlucky on the memory sticks. Or like the board is like that can be sometimes a thing that like the board will affect the TCL, but that's not super common, so I kind of doubt that would be the case. Anyway, yeah, like your TRP makes sense for that voltage, and then your like TCL and TRCD just don't. Like they just do, like they just don't. Anyway, TRDs 4416 good. WTRs are a disaster. Are they bugged out or something? Like why are they both at 14? 26, that's auto. TRFC 290, okay. SCL's at 4.3, yep, and RTP 6, and then TWR 15. That's really loose. Yeah, why is that at 15? Is that also bugged out? What's with the black squares? Like, honestly, I would try to see if this works better at 3800 or something, because this just isn't looking good in terms of timings. Are not done. Oh. Well, once you're done with these, I would still consider testing if, like, at 3800 things behave better. Because the primaries are just awful. I mean, I doubt awful primaries are awful enough to offset the benefits of 2000 FCLK, if that 2000 FCLK is stable. Because, yeah, the rest of the timings, like, I'm assuming, like, if you tighten all the other ones, like, to what they usually end up at, then this will be fast, even though the primaries are just like, whoa, that is so bad. Um, and I have lost the track of what I copied out. I got 14, 15, 8, 11, 21 at 3800. Yeah, that makes sense. But wait, at 1.6 volts? Man, that still sucks. This is like really, like, if you need 1.6 volts for 14, 15, that, like, yeah, that's bad memory sticks. Anyway, do I do one more? Or do I end it here? What time is it? That drive strength true? What, clock drive strength 60? Yeah, that's fine. I mean, it's a bit weird to see that, but, like, that's a B450 board, so that might make sense. Wait, you have your, like, setups set up for, like, not having gear down mode, or at least it looks like you're trying to disable gear down mode, but your gear down mode is still turned on. I would probably, like, hurry up and turn that off first. Like, I would probably worry about gear down mode before I worry about anything else. What, that SOC voltage? Mm, I mean, I've never seen it scale that high on, like, a non-APU. I've seen APUs scale to, like, stupid SOC voltage. I think I got 2400 FCLK to work on my 4750G by, like, shoving 1.4 SOC into it. Was it 2400 FCLK? Yeah, I think, like, 2400 FCLK. And actually, it might have been, like, 1.45 SOC. But that's an APU. Those are very different from the CPUs. So yeah, this is looking weird. Have you ever tried to OC ECC or load reduced RAM? No, because I generally don't do server hardware. Higher FCLK doesn't like low SOC for some reason. No, that would potentially make sense. Like, if FCLK was to scale with something, SOC voltage being one of the things it scales with would make sense. It's just, like, in my experience, like, my experience, like, I've tried, like, I think even, like, 1.3 SOC with my, like, 5950X and my 5700X3D to, like, see if that wouldn't brute force the FCLK above 1900, and it just didn't. So, yeah. I mean, I'm not sure I'd be super comfortable running 1.26 SOC, though, every day. It's probably fine. Um, but the thing is, well, you're on a B450 board, so that's not really a concern. But as far as I know, like, the PCIe starts, like, bugging out at like, once you push SOC above 1.2 on Ryzen. What do you think of the Gigabyte Z790 Aorus Elite AX? Well, it supports Intel CPUs, so... Are you really sure you want to have an Intel CPU? The board itself is fine, though. Does he know how to check WHEA errors? You just scroll down to the bottom of hardware info while running stress tests, and you'll see the errors showing up. I mean, at this point, everybody should be aware of the errors that you get with too high FCLK. Have no WHEAs. Also, like, you get, like, audio cuts if your FCLK is unstable, which, like, are pretty noticeable. Oh, I guess I should pull up the subs are closed there. And I think, oh wait, no. So okay, there's one more because somebody posted something that's like relatively interesting instead of bland and generic. I mean, this was pretty interesting. Like this has all kind of weirdness going on. Yeah, Z390 is not something we see very often. This is Hynix, isn't it? 4266, 1823. Oh, wait, no, this is Micron. That TRFC is way too high for Hynix. Wait, what? This is Hynix and you're at like 640? No, that's... I'm pretty sure that's way high for 4266. But 1823, 2342, 2T command rate. Right, the RTLs are awful because the primaries are awful. Like, it does look like they're actually, like, they aren't... Like, they are tightened because the IOLs are at, like, 7 and 8. But, yeah, like, they ultimately still end up, like, over 60 just because your TCL is 18. But anyway, so 7, 4, 11, 9... What? WTRS normally goes way below WTRL. Yeah, what? Like, it might be Hynix things, but this seems unnecessarily loose. Your right to reads. DG especially. Like, you should be able to have DG at, like 8 cycles below SG, usually. Or more even sometimes. Actually, no. Like, usually it's, like, 4, and then, it's not, like, a lot of the time it'll go even more lower than that. TFAW is awful. Now it should be 16. There's just... If you're on DDR4, there is never a reason to not have TFAW at 16. Because if, like, you can just control the stability with the TRRDs. RTP8, TREF I maxed out, cool. I'm starting to suspect that TRFC is on auto. And then 7, 4, 7, 7, 16, 16. This should... I'm pretty sure those can get tighter. And then the dual rank timings, well, those don't matter because you're on single rank. So, yeah. Nice that it works at, like, reasonable system agent, right? 1.3 instead of something ridiculous. Yeah, TFAL 36 is awful. I said. That's, like, the main thing I would fix, and then, like, the read to writes and write to reads I think could go lower. I also wonder if TRAS couldn't get lower as well. Anyway, that'll be it for today's Reacting to RAM Timings live stream. Because the WTRs, yeah, I know that's why. Also, the WTRs are calculated backwards from the WRRDs. Like WRRD is the actual register on the CPU, and WTR is just calculated by software. But yeah, like, those WRDs are awful, therefore the WTRs are also awful. Like, that's why I switched over to the WRDs, like, while I was talking about the WTRs. Oh, you can do them both ways. Yeah, it depends on the board. I prefer setting the ones that are actually physically on the CPU instead of the pretend timings that the BIOS includes. So, anyway, yeah, that'll be it for today's stream. There will probably be another one next Sunday. Thanks for watching. Thanks for all of the super chats. If you'd like to support the channel in other ways, there are links in the description, or at least there should be links in the description. And yeah, that's it. So thanks for watching, and goodbye.